All right, guys, welcome to our third video going between mass and mass of stoichiometry. We've already figured out how to go between moles of one substance and moles of another substance. So hopefully you guys have your video notes out, and I also want you to have this out. I gave it to you the first day we started. We may have not looked at it very much, but I want you to take it out now. So pause the video and go find this Stoic roadmap because we're going to use it throughout. All right, so let's get started. So, for stoichiometry related to mass, this is when we are starting or ending or both in mass. They're more realistic because we can measure in the lab mass very directly, right? We can stick some sort of substance on a balance and figure out the mass. It's much harder to figure out moles. You can't weigh moles, right? But what we're going to do is we're going to use molar mass to convert to or from moles. So molar mass, again, is a number on the periodic table on the bottom, where we take this number to 2 places past the decimal. For compounds, you might need to add them up. We're going from one substance to another. So 2 different elements or compounds. And when I say all roads lead through the mole, what I mean is to go from one substance to another. We need to cross over with a mole ratio. That is the only way we can get from one substance to another. We can go from, otherwise you're only staying at one type of substance, one piece of our chemical equation. And that's why those mole conversions are important. That's why coefficients are important from our balanced chemical equation. They still really, really matter here. All right, so we're taking it one step further. All right, so let's do some problems starting with mass. So this process is going to look very familiar. It is going to look just like our dimensional analysis. Which is the same thing as the factor label method. Okay? So, just as we did, first we want to identify the given and the wanted. I'm going to switch colors around here. All right. So we're going to select the mole ratios with their coefficients from that balance equation. All right, so we need that just like we did in the past. Then we're going to set up our calculation. All right, so take out your stoichiometry roadmap, put your finger on, let's go look at it. We're going to start with moles of substance A, and we're going to go to grams or mass of substance B. All right, so we have 2 steps to get through. All right, and it says here that this step we need to use the molar coefficients, the mole ratio. Then we need to use our molar mass. All right, so keep this out next to you to use. I'm going to flip back and forth. Oh. Okay, so take it out. Put your finger on, does it say starting with mass? Oh, yes. Oh, I did this wrong. Sorry, guys. We're going this way. It said starting with mass. So we're going to go from mass to moles. So first, we're going to use molar mass. Second, we're going to use a coefficient. Sorry, guys. All right. So mass to moles. Follow the road to get from beginning to end. So first, we need to use molar mass. All right. First, multiply the mass of your given quantity by the molar mass. So mass of given, whatever number you're given in a problem, put it over 1. Multiply it by molar mass. Molar mass of the given will go on the bottom, and 1 mole will go on top. All right, so that way our masses will cancel out, and we'll be left with moles. Then we're going to continue the problem. It's going to be more than one step, right? We said 2 by multiplying by some number moles of the wanted over some other number moles of the given, just as before. And in this case, X and Y are coefficients of the wanted and the given. All right. In the balanced chemical equation. All right. So, start with mass of substance A. Go to moles of substance B. Follow the roadmap, right? We always want to start with one thing on the left. And remember, units need to be opposite the fraction line to cancel out. So that's one of the main goals as well, just as it was in the beginning of the year. All right, so let's hear our reaction. First, here's our reaction. We need to determine the moles of NH3. So this is what we want to find out. Let me highlight it with green. This is the wanted. And what we're given is this. This is a given. Sufficient nitrogen just means we can ignore it. So put a little line through that. Okay. So what we're going to do, as before, it said first, multiply the mass of the given. So let's start with the mass of the given. 16.2 grams of H2. And now, looking at Stoic roadmap again, we're going to go from grams to moles of that same substance. When we do that, we've got to use molar mass. So let's put grams H2 on the bottom and look at our periodic table to see that the molar mass of 2 hydrogens is 2.02 grams per 1 mole H2. It is important to label that there. Okay, so we have successfully gotten from here to here. Now we're in moles. Next, we need to get to moles of another substance, and this is what we're going to use those coefficients for. All right, so now let's take this ratio of coefficients and put it in the bottom. So set up an equation, another multiply line. Given units go on the bottom, right? Given on the bottom. So what we're going to do is our given is hydrogen. So it's going to be 3 from the coefficient, moles of hydrogen, matching up with our wanted coefficient, which is ammonia, 2 moles of ammonia. Do our units cancel out? Grams hydrogen, moles hydrogen, moles hydrogen, were left in moles of ammonia, which is what we were asking for. So do the math and you would get 5.35 moles of ammonia. All right, let's do an example where instead of starting with mass, we end with mass. So what we're going to do this time is we are going to start with moles and end with grams. So we need to go over here. We do that by first going here. First, we need to use the molar coefficients. Then we need to use molar mass. So we're just kind of switching up the order. Okay. So first, identify the given and the wanted. All right. Then you want to select again those mole ratios with the coefficients from the balanced chemical equation. And then set up your calculation. So take that roadmap out and look at it. Put your finger over here and another finger there. And there's our 2 steps. Follow the road through the end. So first, you're going to multiply your moles of your given by X moles of your wanted over Y moles of your given. And this one again, this is the mole ratio. It gets us from one substance to another. Moles is the only way to connect those 2 things. Next, you're going to multiply by the molar mass. So in this case, it's going to be, it's going to end up flipping. Because now we've crossed to the other substance. So now we're in the wanted. Let's see how that works out. All right. So here's our reaction. Same reaction as before. Here are my coefficients. Oh, I meant to use a highlighter. Okay. So we just highlighted the coefficients that we're going to use. Remember, when we set this up, it's all about our units being opposite the fraction line in order for them to cancel. All right. As always, we always want to start with the given. We want to take our given value and start with it on the left. So 23.8 moles of hydrogen is what we're going to start with. Set up a fraction line. Now, let's look. So we are in moles of substance A. We're right here. We need to get to moles of substance B. And the only way to cross this line is to use those molar coefficients, to use that mole ratio. So, units, we're going to take now this and plug it in here. So moles of our given, which is hydrogen, goes in the bottom so that those units can eventually cancel. And moles of our wanted, which is nitrogen, will go on top. Then we will connect moles of hydrogen, our coefficients, 3 moles of hydrogen, to remember that's an imaginary 1 there, 1 moles of nitrogen. Okay. So now we have gotten out of moles of hydrogen into moles of nitrogen, but our question is asking for the mass of nitrogen. So we did this successfully. Now we need to go over here. And so we need to use our molar mass to get us there. Okay. So molar mass, we need to put moles of nitrogen down here because moles of nitrogen is up there. So now it's got to be down there so it can cancel. And when we're finding the molar mass, it's always 1 mole of whatever to the number on the periodic table. Pay attention to this time, it's N2. So that means we have to take our 14.01 and multiply it by 2, which gives us 28.02 grams of nitrogen. Moles of nitrogen cancel, and we're left with grams. If you remember from the beginning of the year, how we solve this, multiply, divide, multiply, divide. We do that, it gives us 222 sig figs grams of nitrogen. All right, so each of these were both 2-step problems. Now we're going to start and end with mass, which will give us a 3-step problem. All right, but we can do it. Okay, so in this case, both are given and are wanted in mass. First, we need to convert grams of our given to moles of a given, because it's got to be in moles to get to the different substance. Then we need to convert moles of the wanted, after we can use the mole ratio, to grams of the wanted, which goes like this. Mass grams, or mass given, moles given. I'm going to switch colors because we're switching substances. Moles wanted, grams wanted, or mass. Say mass. So going from mass to moles, we use the molar mass of the given substance. From moles one thing to moles of the other, we use a mole ratio. And from moles wanted to mass wanted, we'll use the molar mass of the wanted. All right, so let's look at our roadmap. Let me erase all this. So what we've got is we're going from here to here. First, grams to moles. Then we need to cross over. Second, mole ratio from the balanced chemical equation. Then molar mass of our second substance. Keep that next to you and use the steps as you go. All right, new reaction, new balanced equation. Here's our coefficients. All right, we need to determine the number grams of oxygen, which means this is our wanted, required to completely react with this many grams of phosphorus. That's our given. All right, so take out the roadmap. Remember, use dimensional analysis, and units need to be opposite the fraction of the line to cancel. Okay, so let's do this all in one step. I'm going to break it down as we go, but it's basically going to be one step. So first, start with given. All right, always want to take our given number and start with that on the very left. Over 1 if that helps. Set up a multiply. Now we need to go from, just trying to switch up the colors, mass to moles. That's our first step. We do that using molar mass. So molar mass is grams per mole. Grams of phosphorus needs to go on the bottom so that these two can cancel out to 1 mole. Then you need to look at the periodic table to find the molar mass of phosphorus, which is, let's see, 30.97 grams. Okay. Make sure we label that properly. So now grams of phosphorus are done. We successfully went from here to there. Check. Step 1's done. All right, now we're in moles of still what we're given. So let's set up another fraction. Next, we need to go from moles that were given to moles that are wanted. This is our second step. So this is the mole ratio. This is how we switch substances. So what our units need to be moles of phosphorus on the bottom so that these will cancel. And we want our moles of our wanted on the top. So let's see. What do we want? Moles of oxygen. Then we need to take our coefficients and connect them. 5 moles of oxygen. Imaginary 1 mole of phosphorus. All right. That ratio is always wanted over given. Always. Here's our wanted. Here's our given. Okay. Now, moles of phosphorus will cancel out. And we need to now bring this moles of oxygen down here so it can cancel out. And what we're doing this time is we've gone successfully to moles of substance B. Now we need to go from substance B moles to grams. So we're going to use molar mass again, but on the different substance this time. Moles of oxygen need to go on the bottom because they'll need to cancel out, right? Molar mass is always 1 mole of oxygen. And because it's O2, we need to find our number of grams of oxygen on the periodic table, but then we need to multiply it by 2 to take care of this. And it's 16.00 for 1, so 32.00 grams for 2. Moles of oxygen cancel. We're left with grams of oxygen, which is what we wanted. Now we just got to do the multiplication. Multiply, divide, multiply, divide, multiply, divide. Plug it in. I'll give you guys a minute to plug it in. So pause the video until you think you've got it. All right, hopefully you guys have had a chance to plug this in to your calculator. And we've got 50.6 grams of oxygen. And we use those sig figs to match what we start with. All right, so that's the longest it's going to get right now. Actually, that's usually the longest it's going to get. How about you try it? All right, use the roadmap to do this. Let's together first identify the wanted and the given. So how many grams of oxygen, this is the wanted, are needed to fully react with, combustion reaction, 84.7 grams of benzene. All right. Here are your coefficients for your balanced chemical equation. Set up all the steps. Use your roadmap. Remember that you need to have units opposite of the fraction line. All right, pause it, give it a try, and when you unpause it, I'm going to go through the whole thing. All right, hopefully you've given it a shot. Let's do it. All right, so back to our roadmap. Let me erase all this. We're going again from grams of substance A to grams of substance B. So first, we need to use our molar mass to get there. Second, we need to use molar coefficients to swap substances. And then third, we need to use molar mass again in our second substance. Okay. So we're always going to start with our given. This is benzene. I'm just going to write C6H6 because it's shorter. Okay. Over 1. Now I'm going to use my molar mass. So grams C6H6 needs to go on the bottom, so those cancel. And 1 mole C6H6. Make sure you're writing this with each step. All right, it's important. So, we got to find the molar mass of C6H6. That probably took you a minute, but it is 78.17 grams. 6 carbons, 6 hydrogens added together. All right, grams of C6H6 cancel. So we have successfully gone from grams to moles of the first substance. Now, we need to get from this to this. So we're going to make our wanted over given ratio, which is oxygen over C6H6, and the mole ratio. So it's 15 moles over 2 moles. Plug that right in. 2 moles C6H6, right? We got this 2 here. And 15 moles oxygen on top. We got that there. Lines it up this way, wanted over given always, so that our units can cancel. And now we've successfully gotten from one substance to the next. Last step. We need to go from moles of oxygen. Make sure those units cancel out. So moles of oxygen needs to go down here. And then we can use our molar mass. 1 moles of oxygen when we're doing molar mass. And again, it's O2. So it needs to be 32.00 grams of oxygen. Moles cancel. We're left with the right thing. Plug this into our calculator by multiplying, divide, multiply, divide, multiply. Divide by 1 technically. And your answer is 260 with a decimal after, or you could have put a line for sig figs, grams of oxygen. All right. So it says it, I believe, at the top of your handout that the reading, if this totally messed you up, the reading is section 12.2 in the textbook, which are also pages 360 to 363. If you're unsure, I highly, highly, highly suggest reading it or watching maybe the video again, because Monday we're going to practice with this. All right, have a great rest of your weekend, and I will see you all in class on Monday.